job management system for Hadoop. So the first question that we got to ask, yes, so is our definition of the term big data? That term is an overloaded term. It's been used in the context of Hadoop a lot. Everybody calls Hadoop a big data platform. And when we decided to use this term, we realized that it was overloaded. But the meaning that we put into it is slightly different. We use Hadoop, but we are building a big data platform around it. So our term includes Hadoop plus the ecosystem that we are building around it. So the question is, why build this big data platform? To understand that, let's go with this agenda a little bit. What is big data and what is its business value? That's our context. We provide a context for this problem that we're trying to solve. Right? What we perceive as a problem and the solution that we are giving to this problem. Right? The next item will be big data comes with big problems. Now, a lot of people deploy Hadoop. I'm going to ask a question. I'm going to put it out there to you guys. You don't have to answer it. Is how easy is it to manage Hadoop? How easy is it to manage the jobs that are running on Hadoop? Do you know when your data is coming in? Do you know what data transformations are happening? Do you know where that data is going? Do you know the life cycle of your data? The bigger the data platform, the bigger the problem. We're going to address that. Now, how it works. So then is our solution, StubHub's big data platform. Why we chose to build this, right? How it works and its benefits. So let's jump right into it. Let's look at this guy. So the business value for big data, right? It has huge upside. So the entire conference is about the upside, the benefits of big data, from recommendations to fraud, to healthcare, to business analytics. People want to know who visited my site, how many times do they visit, what are their preferences, because if you can target that, you can get a profile of the user or users, right? The better the profile, the more accurate the recommendation. The better the profile, the more quickly you can see behaviors that are not within that profile, so you can identify fraud. There are certain patterns of behavior for a regular user, for a high-end user, and for a user who's actually fraudulent, right? These patterns exist. How do you find them without data? And how do you find them without a lot of data? Heterogeneous data, not just data that you've written to a database and now you're putting into the data. You need clickstream data, user preference data, relational data, data from Facebook, security data. You need heterogeneous data. You need a lot of data. You need to be able to look at that data and find it, and find these patterns, and what these data patterns emerging within that data. So you can have fraud, recommendations. Customer 360 is the total view of the customer, right? And there's more. It can be used for tracking, social interactions, event updates, business analytics. There's a huge range, right? Data is one of the most undervalued commodities in our system. And I think with Hadoop, what's happening is we're beginning to realize that we are sitting on a motherlode of information which can be used for business. You know, actual benefit to people as well as giving a business a competitive edge, right? So, that's the business value. But there's a problem. One of the things that happens with us is somebody says Hadoop, and it becomes a magic word. I have Hadoop, and my problems are going to be solved. Right? It's fine. This happens, right? As we know, we're technologists, right? The marketing people come and say, oh, you've got Hadoop, I've got big data, it's all okay. Your headache is just beginning, actually. It's just beginning. Because what happens, right? Big data comes with big problems. If you have a 4,000 or 5,000 or 10,000 node cluster, when did the data get imported into HDFS? How visible visible is that? How did it come into HDFS? Where did it come from? How much data is there? How long has the data been there in the system? How was it stored? Where was it stored? And how many different types of data do I have? And what are their sources? The bigger the system, the harder this is to discover. It becomes a black box. How many people who have a loop get email from their manager saying, please clean up your file system? It happens all the time. There's red alerts going out. We are running at 97% capacity. Please clean up your file system. How come the system administrator does not know what your data that you brought in is? How come they don't know? Because there's so much of it. And everybody is doing their own thing. Right? They're bringing the data in. Something is happening with that data. That data is being exported. Each individual stream works. But the system as a whole, how will you discover this? How will you know this? This is one of the problems existing in Hadoop today. I'm taking examples from real systems. I get emails constantly. I won't say from where. Right? Please clean up your file system. Please stop your long-running job. Right? The next question is, what is happening to my data? So is it being processed and aggregated? Where can I get my published data from? Where is it stored? HBase, Hive, HDFS? So what is happening to my data? I brought the data in. There's a MapReduce job for it. Is the job running? When does it run? Is it a batch job? Is it a job that is executed upon demand? How long does the job run? How much of the system does it use? What's its system footprint? Where does it publish the data? Right? What does the published data look like? How do I query it? How long will I have to wait to get my published data? That's the big one, right? I've got the data. When can I get it? Consumers are not concerned about what you're doing under the hood. They have the best technology. They want to know a couple of things. Where is it coming from? When am I going to get it? And the business wants this more and more because they suddenly realize it's like an epiphany. It's like, yes, I need data. I need analytics on this data. I need insight. So the next question in business is going to be, you have Hadoop, when can you give me what I want? Right? And there's an urgency around that because they've woken up to the fact that, yes, big data can give you huge leverage. However, there's something that happens in this black box, and I don't know what it is, and I need to get something out of it. You need to tell me when I can get what I want out of it, and also how accurate it is. Right? Recommendations, you can have some slight fudge factors, right? But fraud cannot have incorrect data. Because the more accurate and the more consistent your data is, the more volume you have, the greater variety of data. Fraud can then act on that data and give you better answers. If you have inaccurate data, fraud becomes inaccurate. And you can't have that. So there is a criticality to this data as well, right? So the more data you have, the harder it is to manage. This is a problem that we see in Hadoop installations, and the bigger the installation, the harder these questions become to answer. Right? So what do we do? Here's our current context, visually, right? If you look here, you can see that the data importers, right? Data imports, the scripts. Mostly we get data through scripts, right? How many of us have Java programs that are importing data? We have scripts. The scripts could be started by cron, they could be started manually, they could be splitted, right? They can be scripts that are written in Perl, they could be written in Bash, they could be written in, you name it. They can be executed by cron, right? Then you have all this data coming in, right? How long does the data live? Where does it live? When should it be archived? Where should the archived data be stored? Where does this data go? Number one. Number two is after you brought this data in, you have cron firing. Most of the jobs, the approach we have in Hadoop is batch processing, isn't it? It's considered an analytics sort of platform, right? Its prime use case, even though now it is moving to become a data hub. In 2.1 of OpenWorks, you have things like Storm, have a near real-time processing technologies into Hadoop because it can do this thing that other data stores can't do. It can scale and it can handle heterogeneous types of data, right? So in this case, the view is that we have batch processing. So one of the things that happens is my data comes in, right? Some batch process kicks off. What batch process? Right. System administrators are using cron tab and cron to figure out what scripts are running. 5 scripts, 5 jobs, 10, 50, 100, 1,000. How are you going to manage this in cron as the system gets larger? Not only that, there's a synchronization issue. Your data comes in at a certain time. Empirically, that job should start after the data that you are interested in has already arrived. You certainly don't want to pick up that data as it is being entered into the system. There's a synchronization issue. So system administrators are going to have to figure out how long your job runs, match the batch, cron job to run after that. Then the job processes the data and it puts it out. There's high inefficiency because what happens is one of these scripts dies. What happens is it fails. Right? Now you're going to have to figure out, okay, I got my job to run, don't have the right data, oops, restart the job. Right? You have to synchronize this thing manually. Right? This is what we consider the current state. There are systems which have a huge amount of cron jobs, data importers, data exporters, data being put into HDFS. At any one time, you are dealing with this system. Do you know what it is? Someone to say, came to you and said, I got my data that is imported here. Tell me what jobs consume that data and where they put that and how it access. How would you be able to track your data to a system like this? How would you manage the jobs? This is what we do today, right? People are dealing with this. System administrators deal with this. Now, some of the things they do to solve this problem are one, they create schedulers here. But what about the data import? People are doing all kinds of things. So I got my file, I drop it into an Excel file, I get some file, I drop it into the local file system and look, and then I import it, I know my job is going to pick it up. Right? What about the profile of this? I know that there's a huge system in which somebody decided to take and analyze 3.5 years worth of quick stream data. What do you think would happen to a job like that runs? What happens if somebody runs a job that just completely absorbs all the system resources? How do we know the profile of every one of these jobs and that they are good citizens of the ecosystem? Right? So there are very real problems around just using it. Right? Because each user is interested naturally in their job. But what about the system administrator as a whole? And the different SLAs. Some jobs, some data needs to be processed very quickly, flow through the system very quickly. Others, less so. For instance, with recommendations. Suppose you have an event like in StubHub, and you know that this event is big baseball, and suddenly it starts raining. You want to be able to analyze that and then recommend to your users, hey, by the way, looks like it's going to rain. The place where you're going to park is no good. Go and park over here. Go to this bar over here and watch the game, or whatever it is that you want to do. Traffic updates. You're going to a game, you've got bad traffic. You want to get the update, you want to analyze it. Hey, by the way, traffic on 280, not so good right now. Take this extension over here, use this exit, go park over here. It's a 10-minute walk or 15 didn't walk down the stadium, blah, blah, blah. This type of thing. And this cannot happen an hour later. So by that time, it's all over. That's it, right? So, there are different SLAs of data as it flows through the system, as it gets transformed, right? So what do we do? Well, we're the brightness? Hold on. That's sound. I'm as bright as I can go, I think. That can get me brighter. Can you get the glass to brighten up to make this a little more bright?
It's really dark.
Okay, so what we propose to solve this problem is that we isolate this problem into three big chunks. One is data import, or what we're calling data adaptation layer. Because data could be coming from Facebook, a relational database, a file system, another service. Each one of these has to have a different interface to interact with that data. Right? Relational data structures are data from a NoSQL data store, like MongoDB, is structured another way. Data from a file system is structured a third way. Data from Facebook is structured a fourth way. So each of these adapters facing outward have to know A, how to communicate and talk to that source, number one. Number two, how to get the data from that source. And then it needs to know how to work with that data in order to put it into Hadoop. Right? So you're taking the data and you're adapting it so that it can be put into HDFS. Right? It's a data adaptation, right? And what we propose is this data adaptation layer is not a script. It is a Java REST service. Now I'm saying REST service in Java. Let's put it this way. We're implementing it that way. We're saying each of these data adapters is a RESTful service that you can stop, and more importantly, or as importantly, monitor. You can talk to this service and say, what are you doing right now? And it will say, I'm importing this data from this source and putting it into this location. Right? So we have these data adapters, right? File systems, NoSQL, RDBMS, you've got a clickstream data adapter, NoSQL data adapter, RDBMS data adapter, data adapters for Facebook, what you name it, right? Now, after these guys load this data, we have something here called a data validation service. Remember we were talking about form, right? Each of these guys talks to the data validation service in Zuki because they belong to the Zuki group. When this guy finishes, he generates an event which goes up to Zuki. This event is received by the data, it's actually received by everybody in that group. The data validation service gets that and goes, oh, I need to validate this data. For instance, RDBMS data adapter says, I just loaded data from this date to this date, and this is how many records there are, and how many partitions and dates I see. The data validation service is going to go to HDFS and say, how much did you say there were? Okay, I'm going to count it. Okay, good. The record count is as you say it is. You told me I have 50,000 records. Behold, I have 50,000 records in HDFS. I will now create the Hive partition for you. And what does that do? That Hive partition makes that data available at Hive. The partition is not created because there's an error. That data is not available. So with clickstream data, what do? We do the same thing except we go one step further. Because it's a file, we actually do a checksum on that data against the checksum of the original file that was going on, and make sure that that data has integrity. Why? Because of fraud. And because of recommendations. We want our recommendations to be as accurate as possible. We want to be as truthful in the data as possible. Right? So we match it against the source and say, this data, we're literally doing this certified. So yes, this data, as far as we know, coming from here into here, exactly. Now what happens? Right? So once he gets that, he says, okay, I validated this. MapReduce service can now go ahead and execute MapReduce jobs. Now this service, this is a REST service. These are REST services. This is a REST service. It's an orchestrator or a scheduler. Right? So then it can go receive that event and take action on it. Either execute jobs, at least to be executed once this data has come in, or validate that the other jobs that are interested in this data have been scheduled and are ready to run. Right? So let's look at how this works. I know this is a lot of stuff over there, but let's go to the next slide because I want to show you how it works. So, what happened? That was you. Okay.
It's magic.
That's magic. I don't know how that happened. I thought I hit some magic button here. Contrast.
50%.
Vivid.
There's a breakfast.
Good? Better? You guys see better? All right, so what happens? Let's look at this. So, basically, one of the other things that we were talking about is that we look at Hadoop as a batch processing system, and because of that, we miss certain things. We miss the fact that infrastructure works of events. Right? If I import data and I finish it, that's an event. Somebody might be interested in that event. Right? When a MapReduce job starts up or ends or has an error, that's also an event or a set of events. Somebody might be interested in that. When data is published, somebody might be interested in that. So we take that into account and we say, okay, let's see how this works. So the first thing that we do down there is the data load and start. Any one of those guys can start data. They may be running periodically. Every day, or every hour, every day at 3 a.m., or every hour. Whatever the time period may be. Let's say they're running, the load starts from whatever data source it is. Right? When it does that, it informs the cluster through Zookeeper, because they're part of Zookeeper group. Now, if you guys haven't worked with Zookeeper, right? Zookeeper is actually inside Hadoop. It's used by everything. Right? Search engines use it for cluster coordination. Sora uses it. Hadoop uses it. Streaming, Storm uses it. Right? It's for cluster coordination. It's like an essential ingredient. If you have a distributed system, you're going to need Zookeeper. And one of the things that it does is it allows you, it's like internally it's like this file system. Right? If you're part of that file system or part of that file system, anything that is written to that file system, everybody who's part of that file system who is listening will get an event. Or will get informed that, by the way, something has changed, here's your data. It doesn't interpret the data, it gives you a byte stream of data. Right? It's up to you as the client to know how to handle that data. The other thing that Zookeeper does is it elects a leader. Now, you don't see that in this picture, and I don't want to go too much into it, but it allows for auto failover. So let's say we'll go into that in a minute. So let's focus on the event-based model right now. So they're all part of Zookeeper groups, if you will. This data load starts, everybody in this cluster is told, data load from this guy has started. Right? They know it. So that data could be taken by a leader and deposited into HBase or someplace else. It doesn't matter, but let's say we can assist that event. Right? The next thing that happens when the data load is complete, we can get that event, and something can happen because that event can be persistent. What will happen with that event? This guy. Oh, I'm very interested in this. You say that you loaded the data. You've told me you loaded these many records, your relational database adapter. I'm going to go down to Hadoop, HDFS, and I'm going to check that what you told me you've written to Hadoop and what's actually been written to Hadoop are one and the same. If it does, it creates a partition, and then it says, okay, good. Right? Validate the data. And then it's going to say, okay, this data validation is complete. Each of these is an event that is being generated, right? When that MapReduce service gets that event, now we divided the jobs that the MapReduce service can run into two big categories. One is the category that we all know and love and used to, which is batch processing. Let's say that MapReduce service, when it came up, looked at all these jobs and thought, okay, I need to run, 20, 30, 100, 1,000 jobs, and they all have their own time. So I'll just put it into a scheduler, off they go. But there's another set of jobs that are event-based, right? So two things can happen when Mars gets that job. He can look and go, okay, who is interested in this data? Oh, I've got 50 jobs that are already running, or waiting to run, or scheduled to run. They're interested in this data. I don't have to worry about them because they schedule their status is active. That means 3 a.m. in the morning, 2 a.m., whatever it is, they're going to process this data. That's fine. But then looks and goes, there's some guys over here who who want to start immediately as soon as this data comes in. So what it'll do is it'll kick off those jobs right away. Right? If it does that, it generates the event. Right? Right? So now, this MapReduce jobs are going to process that data. What we are asking people in our system who write these jobs to do is to say, guys, when you start up or stop, encounter errors, just log the events, generate the events. So now you can see job 1 started, job 2 started, job 3 started, and so on, right? Job 1 finished, right? When it finishes, they publish their data, and the job is complete. What does this do? So if you look at it from beginning to end, and you were to go to a persistent store, you would see that this data adapter loaded this job at this time, it completed at this time, it was validated at this time, it was worked on at this time, it was the job finished at this time, and the data was published to this place. Doesn't it give you an audit trail of the data flowing through your system? So any questions about this? Yes, they are custom built. That's a very good question. What we've done is we've not tried to reinvent the wheel. Flume is out there, and Flume is a great abstraction. Abstract source, abstract sink, abstract channels. What we did is we took that base abstractions of Flume and we built on that. So we're basically using Flume, but we build our adapters on that infrastructure. So what happens is we found out that the channels and the sinks in Flume can be made to a library, and so all we need to do is change the source so that you can get it from all these different sources. So our data adapters are basically Flume extensions, if you will. Now the MapReduce service is our own, so is the data validation service. All of them are REST services, which means that at any time an application or dashboard which has got a web application, hosting a web application, you can see the dashboard is using. You can go to the dashboard and say, this data, where is it? And it can tell you. You can go to a data store, look it up and go, okay, let me track this data. Now you have data tracking. Now you can tell what job ran when and for how long and operated on what days. Because you have an audit trail of events dynamically being generated by an ecosystem as things are occurring. It also means that if you have errors, the data validation service failed, it'll write back to Zookeeper that there was a failure for this particular data adapter. And that data adapter picks up and goes, oh, okay, I need to reload that data set. It tries it again, fails again. If it fails 3 times, we generate an alert. An alarm saying, you know what guys, we have corrupted data. Somebody needs to take action on this. Right? So you can have alerts, you can have alarms, you can have monitoring, you can have SLAs. So we'll talk about that in a minute. Any questions about this? Why we chose this model? Right? So now, yes. Okay, I don't want to go with this one. Now let's look at job management. I went into this thing about cron. There's a slide on cron. I'm going to pass it by because we already talked about cron. Let's look at this MapReduce service and what we're doing over here. Because that's the second part. We talked about the data adapters. We talked about this MapReduce service. Many people have schedulers. Many people know that jobs need to be scheduled. But the schedulers that we have are usually independent applications. They are not tied to a set of adapters on the inbound side, nor to any adapters that you might have on the outbound side. Right? The system is not being looked at as a whole. You look at it and go, oh yeah, we don't want cron to be running all this all the time. It's unmanageable. Let's create a scheduler. But the scheduler is still batch-oriented. Whereas some of the things that you want, especially as Hadoop emerges into being a real-time processing system with Storm and such, and other such technologies, you cannot have that approach because as soon as data comes in, you want it to be processed and you want it out the door. Right? You've got to have something that says, I got my data, go process it. There is a synchronicity. There is, all those data adapters are not all going to work at the same time, right? You might have a data adapter that's picking up data from some streaming source that is continuously flooding pouring data into Hadoop, into HDFS. And another one that wakes up every morning, maybe 1 a.m. in the morning, and decides to load data. They're not synchronized. When they finish doing what they're doing, they will say, okay, I'm done, right? How will you know when they're done or what to do with that data if you don't have events? There's an essential asynchronous nature to the Hadoop ecosystem. And what we're doing is we're saying, okay, that's good. Let that be. What we'll do is each of these guys talks to all the other guys and then we coordinate. Right? So we allow the system to be asynchronous. And we'll also allow it to be batch processing. We allow both to exist. Right? We don't exclude them. Right? So what happens here is we've got these jobs. Now, what we're saying is that in some SCM repository, people put their jobs. We don't write all the jobs. We know that there are people, customers, who want to write their own jobs. Right? We can't write their jobs. They know their data. They know what they want. They know the jobs they need to run. So they write their jobs. But the thing that we ask them to do, they say, you know what, if you're going to use our service, which we recommend, give us a job descriptor. And the job descriptor is a JSON. And the job descriptor basically says, here's my mappers, here's my input path, here's my output path, here's my reducer, and so on and so forth. All the parameters you need to run a job are in that job descriptor, which is currently in JSON. So you give us your artifacts, Python jobs, jars, Perl scripts, what have you. You make sure that the parameters for your MapReduce job, the arguments, are in some type of descriptor. Why? Because when we pick up that descriptor, we are going to configure your job the way that you ask it to do, and then we're going to tell the job runner, the tool runner, to run that job. What does that do? So the first thing is we get the job, right? I put my job.job, right? And over here I've got job descriptor.json, right? So basically it's a deployment descriptor, if you will, right? It's a deployment descriptor for your job. How should this job be run, right? Next step is, right? Load the configuration for the jobs. So we load them in. Then we set up each job and its triggers, right? Which gives you an indicator of what we're using to do this, which is quartz, right? And then add the jobs to the scheduler, tell the job handler to execute the jobs, and then execute the jobs. Okay? And each job handler, when it executes the job, now the scheduler, later on in the life cycle, we can go to the scheduler and say, what jobs do I have running? This scheduler knows about all these jobs. It will tell you, you've got 2 jobs over here, Java, another 2 jobs in Perl, and so on and so forth. And you can actually get the status of the jobs. So at any time you can go to the MapReduce service and say, tell me what jobs are running and what percentage of completion are they. And it will tell you. Because it's going to the job tracker. It says, job tracker, can you tell me what this job number, what it's doing? And the guy goes, yeah, map is 100%, reduces at 33.3%. You return to your jobs, reduces at 33%, map is at 100%, and estimated time of completion, maybe whatever. Put something figure. So now you can ask the MapReduce service for all scheduled jobs, for all running jobs, for the status of these jobs. You can do other things too. You can look at some job and say, you know what, this job is kind of bad citizen because it has been running for like 16 hours. It doesn't look like it's going to finish, and it's chewing up all my system resources. We all know jobs like that. As a matter of fact, most jobs start off their life like that. They have to be tuned not to be like that, because everybody who writes a job very naturally assumes that all the system resources belong to them. This is not an unnatural thing, it's a good thing. Because, yeah, that's what you do. But as part of the iteration of the development of the platform, you have to tell guys, hey, you know what, this query that you're doing, not so good. Break it up this way. This MapReduce job that is consuming all these, a hook job that you're using is doing this. It is not good. We need to tune it. We need to put it in queues. We need to give it different types of resources, such that the job will have a certain profile that can coexist with other jobs. And you can put it in a time slot which may not impact other running jobs. So you should be able to do that with the service. And you should be able to do it through a dashboard. But administrators can do it. End users can do it. An end user can go and say, I don't like the time my job is running, I'm going to stop that. Tell the scheduler, nope, I want you to reschedule this for 2 in the morning. And you can tell the service that, and say, okay, I'll reschedule the job for 2 in the morning. And it will go 2 in the morning. Is there any questions on this?
Job scheduling, is it using some standardized software, or is it actual job scheduling and monitoring the actual jobs?
Okay, so the question is the job scheduler using custom software or depending upon the job tracker? So 2 things. In our notion, just like a big data platform is an overloaded term, job is a severely overloaded term. When we say job, we don't just mean the MapReduce job, we mean the scheduled job, the job handler's job. In other words, let me go back. Well, we can do it in this slide too. This job, from the scheduler's point of view, this is a job. This is a job which has a MapReduce job. This MapReduce job When we go and monitor, we go to the job tracker to monitor this. It's not customized. But this schedule is, we're using Quartz, right? We're using Quartz, which is a really nice framework for scheduling. So when we ask, the service, what is the status of this job? It goes to this guy, it knows this guy's job. And then it says, hey, what's the status of your MapReduce job? And he goes, the status of my MapReduce job is this. And that's the status we do. Right? But if you want to go to the scheduler and say, hey, scheduler, how many jobs have you scheduled? I've got these many jobs scheduled, this is their name, this is their triggers, this is the time they're supposed to run, blah, 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 blah. And then you ask them, by the way, are any of these jobs running? At that point, it goes and checks and says, you know what? Let me go to the job tracker. Say, is this job running? And it says, yes, the job is running, and it returns the status. Does that make sense?
Small question. The scheduler must be persisting this data somewhere, or persisting inside the database or outside?
That's a very good question. Currently, the question was, where does the scheduler keep the jobs? Persistently, internally, or in Hadoop? Currently, we're using in-memory, so when the job map use service goes away, it'll go away, but we want to put system in Hadoop. It comes with an inbuilt JDBC connector, so you can store it in a data store, like a database like MySQL. You can just store that data in there. It comes with built-in object models for that. So then when you start up, it goes over there, looks at all the jobs that it has, starts them up.
When you say built-in Quartz?
Quartz has a built-in JDBC connector. Right? And it also has built-in models for storing the jobs. So it has a job model, right? A data model, right? So it will create those tables for you and write to them. So you don't have to do a lot of work for that as well. So that's a good question. Yes.
So it seems like bringing good old parts schedulers to which I see as actually scheduled. What are your experiences? What are the user experiences like? When do they stop? Where do they ask these questions? How frequent is that? What is the real value of asking all the time? Because in my experience, you just want to trust.
Yes.
I understand why so interested in knowing everything.
Yes, that's a very good question. The question is why do this? Why know how your data is being tracked? Why know when your job is being run? Because when business comes to you and asks you, I want my data, why isn't it here? What are we going to answer?
The log file, everything has stats.
It has the log file, we have Splunk. It'll give you lots of data. And you go to a thing and you put this report and you send it up to business. Business goes, that's great, but I have no idea what's going on. When do I get my data? What happens if you want to troubleshoot a problem? One of your scripts failed. Oh yeah, I got failed, let me rerun this job again, let me start it again. You can do that, right? But if you have a dashboard that the business goes to and clicks on the dashboard and it says, your job is 100%, your job is 80% complete, that has huge business value for the business as well as for us. Because now they're not sitting in the backseat of the car and going, are we there yet? Are we there yet? Are we there yet? They're not doing that anymore, right? And they become partners in how the work is being done. They have visibility into the system. You've made business a partner in what you're doing. It is not an outside entity in which they're coming to you and saying, give me this, and you have to go through some arcane process that they have no idea about and hand them the results. They go, okay. Now they can go in and look for themselves, and the system is telling them, here's what it's at. It changes the business dynamic. For one, that's one of its values. Right? It also makes debugging a lot easier. If you know a job has failed, you can get to it immediately. So one of the principles of agile development is to have stakeholders all on the same page. When you have a technology center of excellence that the business has to go to and meet with, and then out of this mysterious area comes this report from time to time, business is not sharing in that. And I can tell you from personal experience that it is very frustrating for the business. It's also very frustrating for technology. Because you go, these guys are irrational. They don't know what it takes to do this. They're going, well, these guys like to hide everything and they don't give us the stuff that we want. Have we experienced that? We've all experienced that. By making the system available to everybody to view, you've cut that noise to half. You've now made the system available, friendly, monitoring, proactive. Not just the business. How about DevOps? How about DevOps? Right? You haven't taken development operations into this, right? So you had another question, sorry.
I meant to say that I've had similar experience in other things, not in Europe. And one of the frustrations was that the users always stop looking at the dashboard if they stay more hours. So imagine if you have half the job trading all the time, they will, in my experience, they don't like the dashboard anymore. They always want to see that. So is it only to ensure monitoring for certain kinds of users who want to know all the time? Is there any other value in the job itself? Because if you write a good job, should we take that off?
That is a very good question. That's a very good question. So the question is, do you all get that question? It was like, what's the value of just having this job, the MapReview service that's running, and if you write a good job, it's not going to fail that often. Whereas if you write bad jobs, you're going to get a lot of failures, and the business is going to go, we're not even interested in this because it's failing all the time. So there's a couple of answers to that. One of them is in this guy here. There's something that I didn't show you guys yet. So I'm going to jump ahead. So you're going to have to bear with me a little bit. I'm going to jump ahead all the way down to here. This is a deployment architecture. On the left is the zookeeper ensemble. Right? On the right is each of these jobs. This MapReview service, notice 1 and 2. Data validation, 3 and 4. Number 5 is RDMS data adapt, and the numbers start from 1, 2, 3, 4, 5 again. Each of these is a virtual machine. Right? Configured in a certain way. The active cluster is all the odd numbers, or even numbers. Well, there's one over here that's odd. Yes, this should actually be, this is an oddity over here. But anyway, you have distributed throughout your hardware these virtual machines, each of which belongs to a zookeeper group. Now remember we were saying that zookeeper, if 2 guys belong to the same group, it will be elect a leader. Leader, replica, leader, replica, leader, replica, or active standby. In this case, what happens is the active, since it's been elected leader, says, I'm the guy who has to process everything because I'm active. Standby goes, I'm a replica in this group. I take no action, I'm quiet. If this guy goes down, within milliseconds, zookeeper will elect a new leader. Which means there is no intervention from DevOps. A new leader is elected immediately, a notification is generated, and the system heals itself. The reason for building a system like this is not just we want to be able to schedule jobs and tell people where their jobs are at. What we want is a system that does not fail, or at least is fault tolerant. So the reason for this architecture, there's another reason which I think your question is going to the heart of, is why build this if all you're going to do is have a way of tracking the data. We're building this also because each of these systems is part of an ecosystem which is fault tolerant. Something fails, another guy comes up and takes over. And the dashboard is notified DevOps. Right? So the system has a second very big function, is to allow users to know the flow of data through their system. It also allows DevOps to know how the system is behaving as a whole, and it also allows the system to be fault tolerant and fail over gracefully in case of errors, hardware failures or errors. So, okay. So I just wanted to talk a little bit about data streams. I don't know how we're doing on time here. We have 10 more minutes. So we were talking about flows of data. Data comes in, the process. So you can actually have now in your system, because of this event, of these events, you can follow, you can have an audit trail for your data, right? That means you can isolate, you can identify that if the recommendation jobs are processing this data, you can say this data was processed by this recommendation job and put out here. That becomes a data stream. And you can configure the system to monitor these streams. They're virtual entities, right? Because when the data comes in, it comes in raw. Data adapter has no notion of the stream. So I give you some RDMS data, I give you some user preference data, I give you some other data over here, no SQL data, whatever. I give you all this different types of data. When the recommendation engine picks up that data and it goes, let me take this, and start using it. The moment it does that, it says, I am using this data and I'm running this recommendation job. That means you can now say that this raw data that came in here is now tied to this recommendation engine or recommendation processor, which goes and output over there. Now you can have that and time it and say this is now a data stream. Is the other value of the system. You can give that data stream an SLA. You can say the SLA for this data stream is X. The SLA for the clickstream data is Y. The SLA for fraud data is Z, or whatever the SLAs are. And now you can instrument the dashboard to say, if any one of these guys is not meeting the SLA, you can generate an alert or the not. So you are now, there's an abstraction you can put on the system called flow processing or data stream processing. And now you can put SLAs around it. And why is that important? It's important for when you go into near real time. And your SLA for a certain amount of data is very, very bad. And you want to monitor at any time if you are not meeting the SLA because you want to tune the system such that your system is now more responsive. If you did not have this infrastructure, you would actually be tweaking individual parts to get it to work and you would not be sure of its outcome. But because you've created an ecosystem around it, now you can do those type of things. That's the other benefit. Yes.
So if the system is event-based, how can you have SLA? You have to have a scheduler or something to put them in the queue.
The scheduler, we have a scheduler.
So event-based looks at the SLA and then gives it to scheduler based on the SLA?
So it is working. The SLA is a virtual construct. So the question is, if I understood correctly, how will the entities participating in that SLA know what the SLA is, right?
Yeah.
They actually don't. What they're doing is, data adapter loads the data, generates an event. Validation validates it. Mapping service gets it and goes, oh, this is an immediate one. Schedules it to run immediately. There's a scheduler which can run immediately, or the scheduler can run over time. So it can do many things. It can say, run this job immediately, run this job every 2 hours, and run this job 5 minutes after 1 or 5 a.m. in the morning. So the scheduler can handle cron expressions, but it can also handle real time. It says, this needs to run it now. So you just execute the job, off it goes. Now, as they're doing that, each of them is generating an event. They're laying down like a cookie trail, right? And each of them has a time. Now, you have at the top level of your dashboard said, this process processing flow of the thing should take this long. But you know what? It is taking longer. Why is that? This is not good for our business because we need this data. At this time, you're taking this long to process the data. That's no good. So how do we tune it? Now you can go back to infrastructure. You can look at that event flow. You can see the things that are happening. You can say, here's where we can optimize. Here's where we can optimize. Here's where we can optimize. Now you can optimize your system to be more responsive. You can get rid of any time lapse. You can reduce them. Right? This notion is really important because actually this is what is happening under the hood. There are data flows, there are processing streams. Right? And now you can identify that there's one more thing. See, for fraud, there's recommendations, and for fraud. Fraud has a totally different SLA because fraud is doing huge number crunching. Right? These guys want to know everything since the dawn of time zero since the Big Bang if they could, right? All the way to the present. And they want as much of the data as they want, as you can get, as many sources as you can get. And they're going to go through that data and as data scientist says, get the signal out of the noise. They want to find that signal, right? And to do that, they have to run a lot of algorithms so that they get rid of the extraneous data elements such that that signal comes through, right? If they don't have the data, they cannot accurately, that signal becomes less accurate. So now their SLA is going to be much longer. But the data integrity requirements of that SLA are much higher. Right? I'm not saying that recommendations do not have a high degree of data integrity around it. It does. But you can, there's a slight fudge factor. You can be slightly off. No one is going to really mind so long as you don't do something really strange. It recommends, something to somebody who's like, what? I'm not that type of person, right? But by and large, right? It's exact, but I would say that fraud is much more exacting. It's much more precise, which means that you have to give fraud a lot more to work with. Right? So there are processing streams in the system, and they will have different SLAs, they will have different data requirements, but they all have data integrity requirements for very high data integrity requirements. And we built that into our system. That's why we have a data validation service, to validate the data so that when fraud gets it, they can come to us and say, this is what I'm getting, did you give me this data? We can say, yes, we validated this time, this data came in, its raw format is here, here's when we validated it. This is what we found out. So now, we're not guessing. Prior to this time, right, fraud can have a really hard time knowing, because it's got data. How do you know the value of that data? It came in by some process. How good is it? How do we know? Right? So anyway, so here are the benefits, right? Fault tolerant distributed system, service-oriented, REST-based. It's potential for interaction with web-based management applications, scalable, potential for self-healing. You can create policies for data retention. That's the other thing you can do. At the top level of your dashboard, you can say this data lives for a certain amount of time. And at that time, when the expiration date of that data comes due, a job will kick off, take that data from where it is, and archive it, and then tell you where it's archived, based upon your policy. Now, the email, it says, clean up your data, may disappear. Because the dashboard is going to tell you, here's the old data, and you can say, send out an email saying, this is where the data is, go to the dashboard, create jobs to archive this data, or create policies for this data. Tell me where they need to be archived. And now the system itself will look at the policies you've created, us, and archive that data. Now you have a system in which you can see how much data you have, how it's being processed, what jobs ran, where they're published, how you can archive it, SLAs. right? So you have policies for data retention and data archiving, notifications of failures, alerts and alarm for SLA violations, monitor and track data moving through the system, determine and manage SLAs for data streams, and what we call self-healing, highly visible, manageable system. And that's what we call a big data platform. Questions?
Already asked many questions.
Any other questions?
Is it primary stack Java?
It's all in Java. It's written in Java. And we're thinking of open sourcing a lot of key components so that other people can use it if they want to. We're on time. Thank you all.